So, hi everybody and welcome back to the Unreal Engine 5 tutorial series for absolute beginners. This is video 142, and in this video I want to talk about performance. A little bit about performance of the interfaces which we have implemented in our last two videos. And let's show these two interfaces fast again. There was this version where I implemented the interface, which is not colliding with a collider. And when I open up this interface and show you this one, which is, when it comes up here, this one, that was the first interface. And you can see here I don't use a collider, and therefore I had to create a variable. And it is only one version. Of course, you can realize this in different ways. Here I have had created a variable. One of this one I called it interface target here. This one here I made it a variable type of actor, and then I made it editable so I could select it from the scene. That is one way. And the other version here, the other implementation was this box here, and in this version I used the collider. And when I use that collider, doesn't matter if it's a box collision or any other collider, then you can use this nice setup with this node does implement interface, which means you don't have to create actually a direct reference like this one here. We just use the collider input, which is just the collider reference registers anything which is colliding with it, and then we can use this output, other actor or other component or anything else here, so that we don't have to create a reference here in our map, and therefore we are just asking for the implementation. If it's implement our interface, we know that is this other actor, whatever it is one of that what we want to use, and we are using this, and then we just calling it, and our reference target is here, this other actor. And the nice thing about this one is we can now overlap with this collider any object 1,000 times, and it is just calling this little code here, right? Compared to the other version here, I would all the time create a variable or a variable array and then try to reference them here all in the scene. And now we want to talk about performance a little bit, about these two versions compared also to other versions here, which uses, for example, a dispatcher or this get all actors of class or something like that. We talk now a little bit about performance. So let's start. Before we talk directly with this performance of this version here, we have to understand, or let's say we have to repeat fast two things, which is, let me open up this here in my content drawer. I right click, I go here to browse to asset, and this collision box collider here is exactly this blueprint here, which I have already opened up, but I need now this content drawer here. That's why I select this one, dock it here and pop it up a little bit. So what we have to repeat fast is that I can right click here, and when I right click I have here two options which we already talked. One is reference viewer and the other one is size map, and we will talk about this here. We repeat fast this one here because we need this to understand something. All right, and there is one more thing what I have to talk when it comes to performance. I am not diving deep into performance or make it, let's say, the right way, which means you have normally to use profiler tools, and with profiler tools you have to check what performs good and then check all other options with profiler tools and then figure it out. This is the right way to do normally, but this takes a lot of more knowledge, which means you have to read all the profiler tools through and try to learn them and then understand them and then use them. This kind of stuff I skip here, and I concentrate, like I showed you, only on these two options here, the reference viewer and size map, and I explain you one little detail of performance. So with that said, this is only just give you an idea on which you should, let's say, should take care, should take in mind when you are creating, when you are trying to access actors and so on, and when they are talking about performance. So what I want to just say is, this one is not, let's say, the best way of profiling this kind of stuff, because in the end you have to really profile them and check them separately step by step to understand them in detail. Anyway, we make now the light version, which is just enough for starters to distinguish. So what we have here is, we learned here a lot of different kinds, for example, accessing actors, how we access them and how we use them. We have not talked about all use cases and so, but we have talked about some use cases, and the most use case is that we just create an actor and access them, or make a target reference or something like that. So when we go now to this collision box and I want to check how this one performs, we have to talk a little bit about the reference fever and the size map. The size map will give us information about the memory. And let's open up this one here. And this size map, why is this so bad? Let me check this. I made something wrong here. I see now. Because this one should be the good one. Sorry, but I have to delete this one here. I think that's why it's so bad. So you saw already something really bad, right? It was full, and that should not the case. I make it again. I go here to size map, and now you see it's very little compared to before, and this one is this size. We have here two options in this size map. We see here all these kilobytes, and in this case on the right corner it says so what it is printing out right now. It is printing out what all this reference assets or whatever it is take in memory. We are not interested now in this size, because this optimization is important also, but more if you want to reduce the disk size on your, if you want to reduce the disk size, so you would go in this, check the textures, and then check which textures you can replace or reduce or something like that. We are interested more in this memory size, and when I click on memory size, now it changed a little bit, not that much, but you can see it says here now around 11 kilobytes, and this 11 kilobytes is very, very less. That's absolute perfect if you have something like that, because 11 kilobytes is almost like nothing, which means it takes no memory size in our memory, which is perfect. And why is this so perfect? Because we have some gigabytes normally, and 11 kilobytes is considered to be nothing. All right, that is a good sign here, but what means this, the memory size, by the way? This memory size means here in my example, when I need this asset here, so when I place it here in the world, when I start it, that this asset here is probably, is used, which means used means this memory size is used in memory, so it is loaded, and that is also important for load time and something like that. And I think that's enough for now, because I can talk about this more and more, but I think you should read this more in detail if you go into the size map. We need one more info. So here, let's repeat this fast again. What was it? I right click, I go to size map, and then I can check what all these elements are in, right? And then I can check memory size or disk size. Of course, you can optimize both things, by the way, and only just thing. But we are interested also in references, because this memory size is just another representation of references, which means you can see here in this memory size, I have here this block which says BPI interface. This is a big red block in my case, which takes 3 kilobytes. This is the first reference block, and then I have here in the middle one big block, and this is the blueprint itself. So which means, let me show you this one. You see the blueprint which I have here is this box here. When we go to the size map, it says here self, so you can see it self takes 8.4 kilobytes, this blueprint self, but it has here a reference. It takes 3 kilobytes. So references are very important for memory size, which means for loading and a little bit performance. All right, so we have to keep in mind this blocks here means all time different references. This different references means it takes, let's say, the more references you have, the more kilobyte it will take, and depends also on the reference and so on. But you can see here, it's very only one reference I have here, which is this BPI interface, 3 kilobytes. This representation you can see in another way also. Let me show you the other way how you can see this. I go back to this one. This is again this box. Right click and this reference fever, exactly that what I talked before. Now here in size, this is a reference, this is a reference, and this takes so much kilobytes, this takes so much kilobytes. You can see this one here also, but not with the size map and with kilobytes and memory. Here you just see reference. A reference here, this one reference. Important is here actually you see here one more. But this reference here, this on the left side means you can see here this line here, and this arrow means this asset here on the left side need this one. But that's why this asset is not shown in our size map, because we are here and we just need this one here. These two things we need. And when we watched on the size map, it says that's me. That's the middle part, this bluish color here, and the other part which I need. So you can see I have here a reference. It points out I need this here to work. So, and this one is this other part. So with other words, what I want to point out with this one is you can see on the reference viewer, if you ignore all the incoming references, because that's not important for us for loading, but this all outgoing references from here on the right side, it's important for our asset, which means I need this asset, and if I have more, then we have just check only the right side here. So with that said, and with this understanding, we can now all time check what is good, what is bad. But one more word, this reference, what you see here, this line here and this color, is called a hard reference. Again, what is a hard reference? Hard reference means, like I said before, when I get loaded, I need this one at the same time, which means I will load. When I get loaded, this one must be loaded too. And we can see it here. When this asset is loaded, the top kilobytes here will be loaded in memory. So this is also, think about this as well. So if you understand this kind of stuff, that's enough for a starter at start. And later, of course, you can go more in the real debugging tools with really more infos. But this is, first of all, very nice. So let me show you something more here. Here on the left side, we have here a search def line. Search def line means this is just showing one def, which means if I pop this up, it will show me if this reference here has more references or this reference here has more references. We can check this. I scale a little bit back. I increase this number to make it 2. You can see this side here has no more references, which means in this side, it will take here no more size. Because if this size here would have more references, it would be shown here as well. But I can already see here with this size map, there's only this reference, myself, and this BP interface, and there is no more. There will be no more. But on the other side, you can see this one here. We have here other references. And interesting is also this color here. We have here another color, and here another color. Fast to this color. This one I called a hard reference, which means when I get loaded, I need this one at the same time. So which means both get loaded, but you can see this other color here. It's called a soft reference, which means I must be loaded as well. But the difference is I can be loaded later only when I really be needed. So you can determine in this case when this kind of stuff should be loaded or not. So not at the start, for example. But at this side we don't care anyway, because I said this incoming references means we also this asset is used for this kind of stuff, but we are concentrating now only on this side. And here we have, even with dev2, nothing. And like I said, I can already see even if I increase the number here, I will have no more references here. So you can see now I'm number 11 and still nothing, but on the other side you can see it's increased a little bit again. Which means this setup is nice, and this one I can see it too. So this means this this code here, what we have is very nice, very low memory load, which is very good. And now I show you a bad example. So yeah, let's close all. That was a good example. And that was the box here. The box here which I showed you was a nice example. Let's go to the other box here. And my other box is actually a very bad example. And you will see in a moment why. And when I click it, let's watch first of all the code here. Of course, it is a bad example, not really a bad example, but here I have much more code and I have just referenced here many other variables as well. So I will have more references, but that is not the problem to have more references. But we will see what's the problem is. But let's repeat our knowledge, what we have, so we can go. Let's browse to this asset this time. Right click here, browse to asset, and you see it is just this trigger box. And now right click again. And we have again these two options here, size map. With size map, I can see already all references and the kilobytes, or I mean the memory size and this size. Let's click it, and oh my god, what is now? Compared to the other one, this is anyhow full stacked. And first of all, let's start on top here. On top you can see I need for this asset here around 170 megabyte, not even kilobytes, megabyte. And this is this loading, right? Alone to load this one asset. This size, memory size, will be occupied here. Oops, that's not, sorry, that was this size. I forgot to change this one here. So all right, it's a little bit less. Okay, that was this size. Okay, I need around 130 megabytes for the memory size, but still it's similar. We are talking now about megabytes, and this is another dimension, which is bad or good, we will see in a moment. But before we go to our reference viewer, again, you can see here all the referenced things. Actually, all this kind, what you see here is referenced now. And interesting is I can see here already the biggest block. In my case, you can see this is the tree. This one here, it says here BP Infinity 40. This is actually my character, and my character alone takes 131 megabytes, which means the the most, let's say not the worst, the most hard references caused my character here. All right, so we can see it here a little bit. So, and then you can see what all references my character has. Here are too many, but you can see it all if you need them or not. We will talk about them a little bit more. And yeah, let's watch the reference viewer as well. Let's see what this one tells us. And you will see it will tell us actually all these references here, or not, depends. let's go here, right click. Here's our reference viewer again. I click it. And like I said, this incoming references, we don't care because incoming means all time our asset here, which we use, are needed for them. So the incoming assets, we don't care because we care only ourselves and the references which we are needed. And this, which means we're pointing here. You can see this line here is like a pointer. I need this one, this one, this one, this one, and this one. And like, but here is something strange, right? It is here I have only 1, 2, 3, 5 references. And like I showed you before, here we have not 5 references, we have many, many references. But interesting is this one reference, this Infinitive Warrior, has many references. Where are they? And actually, I showed you this this search depth line here. And when I increase this one, now look what happens. This is my start point. This one has only 1 reference to this one. This one has 1 reference, and then here 1 reference, and this is this character here. And my character here has many references, which means this one is the reason why this asset here, what I'm using here, needs to be, also my memory size here, needs now 131 megabyte. Normally, when I compared this one to the other one, here the other one was, this was what? Let's go to this size map. Here I needed around 11 kilobytes. All right, that is a big difference and interesting. So, and now why is this important now to know? The important to know about this one is we can now try to reduce this hard references here. So this, we will talk now about this hard references, because this hard references, what you see here, and if I increase this one a little bit more, you can see my character here has really, this is all the character here. All the character, if I go a little bit more, I go more, yes, it has even more references. So why I'm talking about is all these hard references here are loading, right? If this is a hard reference, this will load it. If all these lines which you see here are hard references, they will be loaded. If the other one are also hard references, they will be loaded. If these are all hard reference, all what you see here in the scene, if they are hard references, they will be loaded here at this point when I need these 2 things here. So here in this point, it's just understand hard reference means I need to load, when I use this one, I need to load all the other things too, and they have many references perhaps too, and they, if they are hard references as well, they need to be loaded. And that's why we have this big memory load time here, 131 megabyte just to load this where is it, this asset here. But let's go back to my good implementation box here. Here in this case here, I set, let's see the implementation first of all. Let's open this one up. And here I have again this setup with my interface, right? And here, actually, I set at the start this collider here and this node here are just making it so that you have no reference at all, because this collider here just checks what is colliding, and then with this node here, does it implement interface? And if it says yes, I can call whatever it was colliding here, which means, with other words, like I compared it before, here I have to create all time a variable like this. A variable cause sometimes this kind of references. Not all time I figured out, but sometimes. For example, interesting is, I don't know if this is now a bug or if this is true. I have to watch it myself because I have not profiled it. For example, this actor here, is not causing a hard reference, and I don't know why. Because normally all these variables what you see here should cause a reference, a hard reference actually, because these variables are needed and these classes need to be loaded. But anyhow, I don't know why this actor class here is not causing a hard reference. What I mean with that is, let me show you this here in my good example, like here. So this good example here, let's watch this one more time. Let's see here the reference fever. Okay, we see there is only the interface reference, and we see, let's go to size map as well. Size map here. You can see here in the size map only I have this BPI interface reference. We can see it here, and there is nothing more. And now when I create a variable, let me create here a variable, but this time not this actor. Let's say I want to create this lamp variable, right? Perhaps I want only made it possible for the designers to select lamps so they don't accidentally click on other actors and then wondering what's happening. All right, let's make this setup, which means I go here to the variable, I set a plus here, and with a plus means I create a new variable. And with a new variable, let's call it just select lamp, blue lamp, yeah, select light, not lamp, select light actor in viewport. Let's call it this way. Let's make this one a BP light, because this time I want exactly allow the designers only to select BP lights, and I call this object reference. Of course, we have to talk about this kinds of stuff also, but not right now. But by the way, here it says object reference and class reference. This kind of stuff are hard references. Here we have also soft references, but careful, this kind of stuff is a little bit different. This means more you can select it, the soft reference, and then you have to load it on your own in certain cases. And we have to talk about this kind of stuff in a separate video. Let's skip this and let's use this object reference. And object reference means, okay, that's what I expect. It makes hard reference, and let's make this one editable, because I want that my for example, that the designer should only select now BP lights in the scene. Now I compile, save, and like you can see, I can select now this one here. He can go now selecting this one, go to details, in defaults here. Here I created this target BP light, but this time it is just BP light, so he can just only select BP lights and not accidentally why I can select other things? Oh, wait just a second. Okay, I have this one here. I have select this one here. Sorry. Now I have click on this one here, and now you can see I can't select accidentally other things. I can only select lights. If let's select it. No, let's select it not. And let's go before we select anything again to our reference fever after we saved all, compiled all, and all this kind of stuff. And now let's watch again. We go here in. We go first to the size map. Is this the size map? Yes, it is. And with the size map, you see I have only created one variable, right? It was this little light variable here. I have nothing changed, right? I have just created this BP light variable as a class is BP light, and a name, made it editable. I have not even select anything, and my size map shows me 100 and let's change this one again to memory size, 132 megabytes on load time. You see, the problem is now that anyhow this this creating of a variable caused a hard reference, and the biggest reference is of course my let's see, we can see here what it is referencing, but let's go to the reference fever and then we can see it even a little bit better. And now you can see, okay, Here is level 1. I see only my BP interface and my BP light. This BP interface I know will have no more references. So I'm concentrating now on this BP light, and let's increase the level. So it is calling a BP trigger active all anyhow hard reference. Then I go one more. This one is this BP trigger active all reference is okay, anyhow, this one is calling the, I think it is the, oh, did I have made this as a child or something like that? Not really. So anyhow, this one is calling, why it is calling this BP other trigger here? I'm not sure why this one is calling the other trigger here. But this one is anyhow calling the other trigger, which means this one is anyhow calling this other one. Makes no sense for me why now, but it is doing this one. I have to see later why. And this one here, of course, is calling then all the other things here. Perhaps I made this accidentally a child of this? No. Or did I? 1 second, I check this if this one is a child or something like that. But no, it's not child. Why it is calling this one? Alright, I don't know why this one is calling this one here. A little bit strange. I have to check this again why this one is happening, because that makes no sense to create here this variable and this one is creating anyhow a reference to this one here. Alright, I don't know why this is happening, but anyway, this is causing a problem. You can see this one is a problem for itself, which I have to check, because it's creating anyhow a reference to something which is not related at all, which is this node here. And this node here, I know we have watched this one, that this one has this other references. I don't get the idea here why this one is creating here a reference to this one. Okay, that's strange. But this kind of stuff you have then to check in profiling why this is happening, then analyze it and then remove it probably and something like that. But in this video I wanted to not show you this one. I wanted to show you more or less this kind of references which is causing. Let's skip this example. No, yeah, it's you see it's a problem which I have to analyze, but not right now. So let's go on here a little bit, and I go again here. And interesting is, let me delete this one here. Now I'm back. Compile, save. Now you can see I'm back to my normal. And let's create another variable. But this time I want to see why this is happening. So let's create one more variable. Let's call this test, just for this test purpose. Let's make it editable, but this time not light. Let's create it, for example, let's see, BP, anything other BP than this one. Let's see, BP enemy eye. Why not? It is just a reference. So now I have an BP enemy eye created. This is any class in my, which I have created anywhere. And now I test the same thing again. Right click, size map, and bang, it is again really big. And now we go again to the reference fever and right click, I mean here, yeah, reference fever. And here we have, but now we can see my BP enemy eye here. That's normal. I have created this asset here, and this asset has many references. Okay, that makes sense. Okay, let's make one more test, but this time not an enemy eye, anything low. BP. Okay, what is this BP? Let's see, enemy eye, not enemy. Let me test whatever this one is. I don't even know what this one is. Let's make a class of this one. And let's see what happens now. We go again, here's size map, and okay, this one has less references. Here's my interface, here is the self, and all this other kind of stuff is this BP decal whatever. But the thing is, when you create a variable, you can see that I wanted to show you normally. When you create a variable, when you assign here a class, it is creating a hard reference. That was the thing what I wanted to show you. I don't know why the other one showed me another hard reference, but here, this interface was at start all time there because I have implemented the interface. I made all something like a function and a variable, but here, this variable I created, and you see a hard reference, and when I extend this one has its own needs, which means it needs this macro or whatever, but that's all it. So you can see it needs only this one and this one for itself. Important to know is now, okay, we learned creating variables makes our size bigger, right? And let's go back to our function, and here the power of this little thing is you are not creating kind of variables like this one here, because we are using this other actor, and that's what I wanted to show, and that's why it's so powerful, because our code will stay all time little and the performance is all time high, because now I can, with this collider, I can refer to any actor without creating this variable here anywhere in my scene. And that means when I have not created anything in my scene, I will not have here any references, which loads up, for example, my memory size here, right? Something like that. I have deleted this one, that's why it's so. But that's the good news. I hope you see this one. And that was just a little introduction to this one. And there is more, of course, but I think, yeah, I talked already too much. Not actually, I never talk too much because there is so much to talk, but I stop here now, I think, because now you can experiment and test a little bit on your own. And like I said, you need to go anyway later to this profiling tools, and this profiling tools will then tell you, okay, this costs much memory or much this size, and then you have to analyze this, and then you have to try to reduce this. And when you are trying to reduce this is the point where you have to think about something like using an interface or using something else. For example, here, this get actor of all class is not good in certain cases, and then you say, can I replace perhaps this get all actors of class with an interface if it's possible, because here we create no variables at all. Here I create a variable, and here one more thing perhaps, if I use just get all actors of class, just this node, you can see something here. I have nothing connected, and just by selecting a class BP, let's say light, here's my BP light, I have nothing selected here. It is just here, compile, save, and this if this node is here selected anything, it is anyhow created already a hard reference. Let me show you this one. Size map, and you see I'm full again with BP light is again here. Just because I have this in my editor, so careful about this. If you have some code which you are not need, just delete it, because this little selection has already created a hard reference and cause also problems. And yeah, here just also the reference viewer, you can see here's BP light. When I watch all what is there connected to BP light, you can see it goes up, which we don't want. And with that said, one more thing perhaps, which is more important. Yes, anyhow, strange, I don't know why this one is happening. Perhaps they solved this behind the scene in a better way. This actor here, this actor variable here is at least not showing this hard references here. I don't know why. Anyhow, strange. You can see I have still this BP light here. Because I have not compiled and saved. Okay. You can see I have here target scene actor, right? It is an actor. It is instance editable, which means I can select this one here. And here I can select now target scene actor. like before, but anyhow, I don't know why this one is not creating hard reference. I don't know if it's a bug or it is really a feature which makes possible to create no hard references even you have selected them, right? Because here I have also created a variable. I have also selected a class and I can select it now in level, which means I can now refer to anything what I want. You can see I have access to this kind of stuff, but I'm not sure if this is a bug or real because the size map is not showing anything here, but it is normally here. It is selected, it is referenced. So I'm not sure about this kind of stuff, but this is not important. It was just a side note. You have to check this probably with a profiler tool here, if this one is creating a reference and loading all this stuff or not. But for us to know is, for us starter important is to know, and we will talk about this one again a little bit, all this other solution. Let's say so you have all time to consider all these other solutions if you want create this variable, because normally they make hard references, and hard references I showed you cause memory goes up, and depends on how many other things are referenced in this hard references, the memory goes up, 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 and more up, and this can cause performance issues. And that's why they say, yes, that is one reason why they say if you have an interface and you have it set up like this one here, it's very powerful because your memory size will not go up at all, because this kind of stuff is not creating a hard reference. And why is this not creating a hard reference? Because it is just creating a reference when it's colliding here. So don't misunderstand this one. This one is also creating a reference, but only at the point where it is colliding with an object. Only at this point, and then you are using it anyway, and that's it. Which means it is not the same as a hard reference where you have to load all the assets which you need at the time when you use it. So this is a totally other concept, I would say, which is much more powerful. And this kind of stuff you have to consider. And that is one reason why they say it's absolute powerful. So it is performance good, and you are not creating, and you don't care about the class type here, because like I said, the class type was also a problem for many starters. Here in this case, you have to find, for example, for cast the right object. Object means you want cast it to BP Lite, for example, and what was the object again? And then you have to find this kind of stuff. And here in this version, you don't have to, because you don't care, because you just check if this what is colliding here implements just this interface, and then you use it. So now I talked about this. You have to consider your options. I will talk a little bit more about accessibility, because there is something which I have not talked, which is, you can see we have not all time the possibility to access it this way. This is a special case. We need to use a collider or a ray trace or something like that. You have to set this up in a special way that you can use this kind of stuff. It's not possible all the time. And then you have to choose probably one of these alternatives, but still you can optimize it in one way or another way. And yeah, I think I make here a break, and in the next video we'll talk a little bit more about kind of stuff, what you should choose, what you should not choose, what you should consider, what you should not consider, because I have not shown you all possibilities. There are some more possibilities which are very powerful but not so easy to understand if you don't know programming. For example, inheritance is one nice thing to know, that we can cast to base classes. Or the other one, which is a very big topic, is also component based actors, which means you add to your actors components, and then you can configure them like the functionality which you want on them with these components, which is very flexible, because you can add these components not only to one actor, you can add this components to many actors. So there are many things we have not talked about. But anyway, we can't not talk all at once, right? And of course, there is also an alternative way, which is probably the most powerful way, which we can't talk here at all, because it is C++. If you dive into C++, then you have other options, I think, again, which is a little bit more powerful than in Blueprint. It's similar, but in C++, they have sometimes other solutions, or they have better performance solutions than in Blueprint. And the reason for that is the Blueprint is, of course, another, let's say, has an interface here which has to be converted, right? You have to convert this interface to the game logic and to C++ later and something like that. And that costs all time overhead and something like that. All right, there is much to talk, but we start and we started here with this size map and this reference fever. If you understand these two things here, it's a good start, and later you can optimize this. Of course, there is also this talk about hard reference and soft reference, how to load it when needed. But this kind of stuff is important to know, especially for a programmer, I would say, because this kind of stuff will be needed if you start to optimize your code, and if you have problems, if it's too laggy and so on, then the programmer should go to profiling and then think about how he can change the code, how he can change all this kind of stuff. The same thing what a designer do with the textures, how he can reduce, for example, here this size when you have your textures, how we can say if we need all-time 8K textures or something like that, the programmer must all-time think if we need all-time this kind of this accessing of a blueprint. You see, I presented here many different ways, different places. You can go also to level blueprint, and like I said, there are so many options, and you have to figure out which one is the best. So it's not easy, absolute not easy, but I think the point when you start with profiling tools and rework all your code, then you will have the best understanding. And anyway, that's easy said than done. But whatever, I talk much. I stop here. I hope it was not too complicated, and just test it a little bit, read about this one, of course, and ask on forums which way is the best way, and ask other people how they solve it. Like you see here, we have many options, but which one to use, right? And there is still one easy rule for starters, and at start you can use this rule. What it works, that works, right? If anything you choose and it works for your program, your project, it's all, and you say I'm finished but all is working, that's okay. After this one it's perfect. But if it's not working and you say I'm finished but it's not working, it's too laggy or something, yes, that is the point where you start to profiling. All right. With that said, I stop here. If you have any questions or any complaints, like all time, write it in the comments, and see you in the next. We will still talk a little bit about this kind of stuff. Bye, good luck, and of course, don't give up.